Wow, so okay, just listen to the last video. I'm going to really have to watch my loud breathing. Sorry about that. Okay, so now we're looking at number 37. 37 deals with 2 magnesiums plus O2 yields 2 Mg. Okay, that's going to be our equation that we're going to use with, and it tells us our delta H equals negative 1204 kilojoules. That's going to be key here because we can use this number as a proportion. That's really kilojoules per mole, which makes it convenient to put into a picket fence. So A is pretty easy. It just wants to know, is that an endothermic or an exothermic? It is exo because it's a negative sign. Heat is leaving the system. Okay, on B here, so B says that we start with 2.4 grams of magnesium. How much heat will that produce when it is reacted with that? So we start like this, and we go, and we're just going to set up picket fences here. 2.4 grams of magnesium. Okay, the molar mass is 24.3 grams of magnesium equals 1 mole of magnesium. Okay, that gets it into moles. And then we have 2 moles of magnesium equals negative 1204 kilojoules. Okay, so we're just taking this and we're finding out how much, if we react 2.4 grams of magnesium with that, how much heat will it give off? We find out that our answer there is negative 59.0 kilojoules. Okay, we're going to set it up the same way for C, except it says it produces, so we're just going backwards here on C. It produces negative 96.0 kilojoules, and it wants to know how many grams would you have to use to get that amount of heat. So now we can just take our enthalpy proportion, and that is in kilojoules for every 1 mole, and we're dealing here with MgO. Okay, sorry, I'm just looking at something here real fast. Catch up on my writing while I just double check some, because I think, and I do believe that I did write it wrong. I did. I'm sorry. This should actually be a 2 because that comes from our coefficient. That's together just like that was together. That's MgO. Always put your units that you'll end up like me, and that would be bad. Okay, so 2 moles of MgO. Okay, and now we just use our molar mass proportion. 1 mole of MgO equals the molar mass, which is 40.3 grams of MgO, and that equals 6.43 grams of MgO. We need 6.43 grams to produce that heat. Okay. Now let's do letter D. We'll change the color so spice it up. I know you'll enjoy that. Okay, now D is a little bit tricky because as you read the question, it's actually giving you the reverse reaction. So if we flip an equation, if we take the reverse of it, then you have to change the sign. That's kind of what Hess's law talked about. If you flip it, you have to change the sign, or whatever you do to the equation, you have to do to the enthalpy. That's Hess's law. And we'll practice more with that on Wednesday, hopefully. Sorry, I just put that line there and I didn't mean to. Okay, we got to wrap this video up here in a minute. Okay, so on D, you start with 7.50 grams of MgO, and you end up with an answer of 1112 kilojoules. Notice it's not negative, so heat was actually taken in because it's the reverse. Okay, so you need to go along and see if you can fill out that picket fence. It's just very similar to B and C.